Hello and welcome to VitoshAcademy. Today we'll be talking about graphs again. This will be our third video in the graph series. The first one was about graph visualization and we have visualized it this way. This is the edge, this is the node A, and this is the node B, the start node, the end node, and these are the edges. The edge is between A and B with weight 1. The H in parentheses is the heuristics. We will not be into this now. Then the second video was about depth first search, and if you take a look, the depth first search on that graph is actually pretty standard. It is this one here. Step 1 visiting A, step 1 visiting B, step 3 visiting E, and then F. Let me show you what does it mean. So it means that first, when the depth first search, we go A, then we go B, then E, then F, and we find here the way. And now we will take this depth first search here, and we would be implementing the next search, which is going to be breadth first search. What is the idea of breadth first search? It means that we will first visit A, of course, then we go in the breadth visiting all this, then visiting all this once more, and we would be visiting all the possible neighbors up to the moment when we reach this one. So this is what we would be visiting that way. Most probably we are not going to visit L, M, N, and O, but let's start implementing and let's take a look. I'll be reusing code a lot because depth first search and breadth first search are really similar. So I'll be saving this one as BFS actually. BFS, save. And of course the file name would be the same, the raw data would be the same as discussed yesterday, and then DFS minimal would be BFS minimal, but this would not be the only change, okay? And then BFS minimal. As you remember from yesterday, BFS minimal actually only returned whether this road exists, the one that we are looking for here. And let's actually not only change the name of the function, but let's change something in the function. What should we change in BFS minimal? Okay, the beginning is perfect. First, let's change here. Let's change this one from stack to queue. We are only changing the variable name, but it is important always to think about BFS as a queue. So this is like a mental thing. So while queue, node would be not exactly stack pop, it will be queue pop. Let me show you the difference between queue and pop. Let's go with this queue, and we have 1, 2, 3, 4. So queue pop would give us 4 and qpop 0 would give us 1. So depending on whether we write 0 or not, it's actually important. And as we all like queues, in the real world it's usually like this. You go to a supermarket and the first in the cash register is the first to be out. So think about it this way. Okay, what else can we change? Yes, let's think about the reversed neighbor. We don't need it. And I like just having it this way. I'm just thinking, okay, let's see whether it works. No, stack is not defined. Probably somewhere I have, yeah, forgotten to do it somewhere. Okay, so this is the absolute minimum BFS, but as discussed yesterday, this is not enough because it doesn't bring us a lot of data. So Let's try once more and go into the bigger function with BFS normal, of course, BFS normal. The beginning is quite okay. Here we have a Q, and while Q, this thing with the 0 is important, everything else should be the same. Just thinking that this should be really a quick video, but it is important to see how quickly can we get from DFS to BFS and vice versa as well. Q append, and I'm just thinking, let's press Shift and Enter in BFS, and it worked. So let's take a look at our place and see whether everything is okay. So visiting A, this is what we did. Then visiting D, C and B. Then visiting D2, I, G, E, I, G and E. Yes, then D3, of course. Then we have J, H, F, and we got a K before P. Yes, and somehow it found, not somehow, but based on the parents, it found the way A to C to G to H to P. A, C, G, H, P. Okay, this is not the quickest one. Actually, in this case, it is the quickest one. But this is one of the things about DFS. It is not guaranteed. But this was the first one it found. Great. Just giving you a hint, this algorithm DFS, it can be used for a lot of games. Actually, if you have a lot of space, you can even solve chess with this one. The point is that after the first move of chess, you have like a lot of alternatives and you need a lot of memory to remember. The problem with this algorithm is that here, right here, you need a lot of memory. You need to remember all the places. And in the chess, the problem is that after the first few moves, this stack is enormous and cannot be remembered that quickly. So that high memory usage is actually the biggest problem of BFS. Yeah, but as you see, it works for searches and graphs where you have no idea about weights or heuristics. The next algorithm would be something more interesting where we'll finally make use of the weights of the edges and probably about the heuristics, but yeah, we will not be anymore just like checking around and making sure that we would find something in the end. Okay, so far so good. This is about BFS. We literally copied the BFS, the DFS implementation, and we changed a few things just to make sure that it works, and it worked. And this is actually the way. Start with something that you know, change it a bit into something that you want to learn and understand how exactly it works. So far so good. This is really a short video. Thank you for watching and staying with me. I hope you enjoyed the code, and stay curious and stay interested in programming. Enjoy the rest of your day or night and take care of yourself. Goodbye.